All right, welcome back to Problem Solved. This is another example that we are going to look at and decide what kind of parameter and therefore what kind of test we should perform here, what kind of test of hypothesis. So we have here the average lifetime of circulated dollar bills is 18 months. Okay, this is something that we hypothesize. A researcher believes that the average lifetime is not 18 months. Okay, that's my claim here. And he researches the lifetime of $50 $1 bills, 50 $1 bills, and finds that the average lifetime is 18.8 months. Okay, this is something that we figure out from a sample of actually checking it out. And the population standard deviation is 2.8 months. At alpha equals 2%, can it be concluded that the average lifetime of a circulated $1 bill differs from 18 months? Okay, I encourage you to pause here and try to state the null and the alternative. Alrighty, hopefully you've done that. So for the null, as usual, we are talking here about the average lifetime. So I need to make a decision about my parameter. What is my parameter? What kind of population characteristic am I after? And I'm here after the average, or we can also call it the mean. So when we're talking about the mean, this is mu. So mu is 18 months. My alternative here is that mu is not 18 months. Okay, so the researcher believes that the average time is not 18 months. It says so. That is my claim here. Okay, and my alpha is 2%. Now, what kind of test am I going to be performing here? Kind of depends on what is the type of standard deviation do I have. If I have the sigma, if sigma is given to me, if the population standard deviation is given to me, I can go with a z-test. If I do not have the population standard deviation and I have to go and use in place of that the sample standard deviation, then I have to do here a t-test. So let's see what we have here. We've got here the population standard deviation. As I have here the population standard deviation, the sigma, I should be able to go and perform the z-test here. Z-test for the mean. Okay, pretty straightforward. You can pause the video here and try to figure out your z-test statistic. All right, so hopefully you got something like this. All right, z is 18.8, which is the observed value, minus 18, which is the hypothesized value, over 2.8, which is the standard deviation given to us, over square root of 50. Okay, we put all of that into the calculator and we end up with 2.02. 2.02. So this essentially for us is our z-test statistic. Now, I can go one of two ways now. I can either compare it on a number line, okay? And on that number line, if this is my 0 and this is a two-tail test, I would have two places which are going to be sort of breaking for me the critical from the non-critical or separating. And in this case, if this is 2%, then my two tail values are going to be positive 2.33 and negative 2.33. Okay, and then I can look on this number line, where does my value fall? So I can take this and bring it over, and it falls somewhere over here, but it doesn't break through this critical region. So anything that is going to be far away from the 0, so these to this side or to that side, is going to be rejection region for me. But we didn't make it into the rejection region. Okay? So I can't reject the null. Or alternatively, I can look at the p-value of what is the probability of getting such a z-score. So probability for z being greater than 2.02, okay, and sort of trying to figure out how does that compare to the 2%, okay? So let's go and look this up. So I'm using this free online University of Iowa app for the normal distribution, and my value was 2.02. Okay, and what is the probability of getting such a value or greater? And it's actually 0.02169. 0.02169 is actually more than 2%. All right, since my p-value is greater than my alpha, I am failing to reject, okay? I'm failing to reject my null. And as I fail to reject my null stands, okay? And unfortunately, my evidence does not support the claim. Remember, the claim was the alternative, and my evidence is not supporting this, okay? The p-value is 2.169%. My alpha is only 2%. And as I am having a p-value that is greater than the alpha, unfortunately, I cannot throw away the null. So I'm failing to reject the null, and my evidence does not support the claim. Alrighty.